Hello, awesome mindsetters, and welcome to it. This is your favorite learning show ever, Learn Extra Live with me, AB. It is a Monday, and we call it a Triple M Day, whereby it is a Mindsetters Math Monday. So we're learning a lot about mathematics today. I'm joined by Natasha again. Natasha, how are you?
I'm very well, thanks, Abraham. How are you doing today?
Doing very well too. How was your weekend?
It was great.
Yeah, this weekend was full of many surprises. You know, there was soccer, there was everything. I hope you also enjoyed it, by the way.
Absolutely, absolutely. It was a great weekend on mindsets as well, because a lot of learning took place.
All right, and talking about mathematics and learning taking place, today some mindsetters were writing their paper 2 for mathematics. I hope also some of your students were writing.
Yeah, I think, you know what, exam times are always stressful, but hopefully with all the learners out there watching Mindset, we made it a little bit easier for them.
Yeah, I'm sure the Saturday live made things a little bit easier. But today, what are we going over?
All right, well, grade 10s, we're looking at Euclidean Geometry, and we're going to go through a couple of theorems and explain to you how you can solve some geometry riders.
All right, and here are the tools that will need you to take part on. One, go over Facebook. Our Facebook page is facebook.com/learnextra. Let's get interacting over Facebook. Have your phone next to you and your calculator next to you, and let's learn more while socializing. Like the page, get your friends on the page, and let's help one another also on the page. Remember, we post our notes also on our Facebook page, so you can download them as an image and have them as we're going over. Secondly, you can download your notes also from learnextra.co.za/live. And lastly, Twitters, follow us on Twitter @LearnExtra. But for now, let the learning begin. Thank you.
All right, thank you so much, Abraham. Okay, so guys, today, as we said, we're looking at geometry, and you hopefully have understood all of the work you've done thus far in geometry. Obviously, most of you have been doing geometry since grade 8, I would hope. And what we're going to look at is Euclidean geometry. Now, geometry is divided into two parts. We get something called analytical geometry, and we get Euclidean geometry. So with analytical geometry, what we do is we look at how we answer questions within space and shape, but we use algebra and a coordinate system, okay? However, with Euclidean geometry, we're still looking at spaces and shapes, but here we're looking at using theorems, and we use logical deductions or conclusions based on these theorems. Euclidean geometry was developed by the Greek mathematician Euclid, hence the name Euclidean geometry. Okay, so that's just a little bit of background for you guys. All right. You will need to know all of the following theorems that we're going to look at. Well, not really theorems, but properties of quadrilaterals. I am going to assume that you already have accumulated all of this knowledge for the remainder of this lesson. If you do not know any of these theorems, if you cannot recall them, remember they are on the website. You can download them from there. I'm not going to go through every single property of every single quadrilateral. I'm just going to show you more or less what you need to remember from each of them. But as I say, all of these notes are available on the website, and you can go at your own leisure and copy the notes down or download them. All right, so some of the things you'll need to remember, and especially for this lesson, it's important to remember the properties of a parallelogram or a palm. It is a quadrilateral with both pairs of opposite sides parallel. The other properties, both pairs of opposite sides are equal, both pairs of opposite angles are equal, and the diagonals bisect each other. Okay, so that's properties of a parallelogram, and as I say, it is assumed in your exam that you already know all of that. It's similar with rectangles, rhombus, kites, and so on and so on and so on. Learn all of the properties. Remember, these will not be given to you. It is assumed that you know these. I'm not going to go through every single one in detail, but you can go through them. As I said, on the website, we've got properties for rectangles, rhombi, or a rhombus, if we're talking singular. We've also got square, trapezium, kite, and so on. So you can read that at your own pace and absorb and make notes if you don't already have these properties. All right. Now, one of the key focuses of today's lessons is going to be the midpoint theorem. All right, so the midpoint theorem, it states that the line joining the midpoints of two sides of a triangle is parallel to the third side of the triangle and is equal to half the length of the third side. All right, so if we have a look at the diagram, so we've got triangle ABC. You have this line DE that's joining the midpoint of side AB with the midpoint of side AC. Okay, so that's your line there, DE. So what the midpoint theorem says is that this line DE will then be parallel to BC, and DE will also be equal to a half of BC. Okay, so those are the two main points that the midpoint theorem is telling you guys. Now, this is an important concept, and you're going to see that even more when we do a few more examples. All right, while we have stated the midpoint theorem, just the converse of the midpoint theorem, it says that if a line is drawn through the midpoint of one side of a triangle and that line is parallel to the third side, then it will bisect the opposite side. So if I draw this for you to show you what this means in a diagram, so if we have some triangle, all right, and we have a line joining the midpoint of one side, so let's call this triangle A, B, C, and we have D here, and we have E. All right, so it says, the converse says, if you have a line DE that's drawn through the midpoint of one of the sides, so we don't know that E is the midpoint of side AC. All we know is that D is the midpoint of side AB. All right, so if you know that D is the midpoint of side AB, right, and you also know that this line DE is parallel to line BC, so you're given DE is parallel to BC and that D is the midpoint of AB, then it follows that E will be the midpoint of AC. Okay, so this is the converse of the midpoint theorem. So if you have one midpoint and that line is drawn parallel to the third side of the triangle, then the side that it joins on the other end, that's also got to be the midpoint of the other side. All right, so let's go straight into some questions using the midpoint theorem. We are asked to find x and y, and we've got a little diagram that's drawn for us. All right, so if you have a look in this diagram, we've got no y, we've only got x. Okay, so using the midpoint theorem, guys, you'll see we've got a few things going on here. We know we don't have sides in that, but we can see these two equal signs here. That tells you that this is the midpoint of this let's call this A, B, C, and let's call that D and E. All right, so D is the midpoint of AB, and E is the midpoint of BC. Okay, now how do we go about solving this? Remember, we're looking for x. Now, since we know that D is the midpoint of AB and E is the midpoint of BC, because that's given to you, all right? So we can say, therefore, ED must be equal to a half of AC. Now remember, with geometry, it's very, very important when you set out your proof to give a reason. So the reason I can say ED is equal to a half AC, we can say that's because of the midpoint theorem. Okay, you need to give a reason that backs up your statement. Okay, so this is our proof. So we know that ED is equal to a half of AC. Now, we don't have any other information. We've got side AB and we've got side BC. We don't have side AC. But if you notice, in triangle ABC, we have a 90 degree. So that means we're dealing with a right angle triangle. So therefore, we can say in triangle ABC, from Pythagoras, we know that AC squared is equal to BC squared plus AB squared. And the reason there, that's just straight from Pythagoras. All right, we know that BC is 8, so we're going to have 8 squared plus 6 squared. 8 squared is 64 plus 36, and 64 plus 36 gives us 100. So therefore, AC will be the square root of 100, and the square root of 100 is 10. Okay, so therefore AC is 10 units. So we know now that the whole length of AC is 10 units, but remember we're looking for ED. So how do we find ED or X? Well, we know that X is going to be equal to a half of 10. And the reason for that again is the midpoint theorem. So therefore X is going to be a half times 10, which is 5. All right, so we had to state a few things first here. We had to say, since this point D was the midpoint of AB, since E was the midpoint of BC, and we know that if that's the midpoint and that's the midpoint, then from the midpoint theorem, DE must be parallel to AC. And we also know that DE must be equal to a half AC. So those are just concepts that came straight from identifying the midpoint theorem. Once you've got the midpoint theorem, then it's simply a matter of application. All right, let's have a look at another example where we need to use the midpoint theorem. Okay. Again, we're looking for X and Y. All right, so if you have a look at this diagram, PST is your triangle. We've got point Q is the midpoint of PS, and we've got R is the midpoint of PT. Okay, so we also know that QR will then be parallel to ST, but how can we state that? Well, it follows from the midpoint theorem. So let's set this up. We can say, since Q is the midpoint of PS and R is the midpoint of PT, right? Therefore, QR will be parallel to ST, and QR will be equal to a half of ST. And all of this follows just because it is the midpoint theorem. Okay, so that comes straight from the midpoint theorem. Okay, now remember, because we have the length of QR, we know that QR is 14, so therefore ST, so we can go from that step. We'll say, well, QR is 14, and that's going to be equal to a half of ST. And remember, ST was given as X, so 14 is equal to a half of X. So therefore, X must be equal to, we divide both sides by a half, 14 divided by a half, tip and times, so we get X is equal to 28. So therefore, ST is equal to 28. Okay. Now, if we're looking for angle Y, all right, and this is why I stated both of the deductions from the midpoint theorem, because if you're looking for angle Y, we're going to use the fact that QR is parallel to ST. How is that going to help us? Well, angle S is going to be equal to angle PQR. All right, I've marked them on your drawing. So PQR and angle S, which is why they're going to be equal to each other. And the reason there, hopefully you can all recognize it by now, that's corresponding angles. And that's because QR is parallel to ST. So angle S is equal to angle PQR. Can we work out angle PQR? All right. Well, if you look at your diagram, you see that you've got angle P is 40, angle R is 60. Therefore, using angles of a triangle, you can work out angle PQR. So angle PQR is going to be 180 minus angle P plus angle R. So that's going to be 180 minus P is 40, R is 60, so it's 180 minus 100. So therefore we get angle PQR is 80 degrees. So that's 80 degrees there. So therefore, since Y, or angle S, is equal to PQR, therefore Y will be equal to 80, and that's because it was corresponding with angle PQR. Okay, so that's just some basic applications of the midpoint theorem. Make sure that you understand how you can apply both the midpoint theorem and the converse of the midpoint theorem. We'll carry on with more examples after this quick break.
Thank you so much, Natasha, and a big shout out to all the mindsetters that are watching, such as Daniel, Zuzi, Letwanelo, Apiwe, and all the other mindsetters. So if you are watching, be on the page, facebook.com/learnextra. We'll see you after the break. Welcome back, Mindsetters. Now, taking a look at the page on our Facebook page, I see there's Nomfundo who's saying that she's enjoying the show. Libya still going along with the lesson. And Matlo saying, today's chapter is so hectic. Would you agree with that, Natasha?
I don't know. I think a lot of mindsetters and a lot of pupils in general struggle with geometry. I'm not sure why. Geometry is one of my favorite sections. I think it's such fun. And I know pupils always get upset because they say, well, the teacher always says that about the hard sections. But it really is one of those sections that you need lots of logic for. And it doesn't mean that if you're bad at maths, you'll be bad at geometry. Geometry really involves a whole lot of logic, and if you follow your theorems and your deductions, even if you're not that good at maths, you can still be good at geometry. So, yeah, it's unfortunate that a lot of people don't like geometry because
it's all
really
in the mindset.
Is quite
We
an
need to change our
exciting
mindset.
subject. Absolutely.
All right, let's continue on that note.
All right, guys, so as I was saying, it really is a very exciting subject, especially if you know all your theorems, because really everything you see in those diagrams, it's going to be based on information that you've already accumulated over the year while studying geometry. Okay, so I know it is a bit daunting for some people, but as I said, you don't have to be good at maths to be good at geometry. You've just got to have a good memory, and you've got to understand logically how things fall into place. All right, so before the break, we did a little bit of the midpoint theorem. We're carrying on with the midpoint theorem, but now we're going to use the converse of the midpoint theorem. This is question 2. So they say, show that M is the midpoint of AB and that MN is equal to RC. So it's two parts in this question, and let's deal with the first one, which is to show that M is the midpoint of AB. All right, so that's the first part. Now, if you have a look at the diagram, you see that they've given you that N is the midpoint of AC. That seems to be all the information that they've given you, but if you look within a quadrilateral MNRB, you've got lots of 90 degrees. Okay, the 90 degrees are a huge help. Why are they a huge help? Well, let's have a look. We know that N is the midpoint of AC. Okay? Remember, we're trying to prove that M is the midpoint of AB. So we're going to use the converse of the midpoint theorem. But in order to use that, we need to know that MN is parallel to BC. We need to know that, but we don't know that. So this is what we're going to first prove. And then once we have MN parallel to BC, once those lines are parallel, then the converse of the midpoint theorem says, since N is the midpoint of AC and MN is parallel to BC, then M must be the midpoint of AB. So it's just the converse of the theorem. So how do we set it out? All right, first let's try and prove that those two sides are parallel. Okay, we can see that angle B is equal to angle M. And we know that because they are both equal to 90 degrees. So angle B is equal to angle M because they're both equal to 90 degrees. But those angles, if you have a look at the shape that they form, it forms an F shape. So therefore, B and M are corresponding angles. So, but these are corresponding angles. Therefore, if they are corresponding, therefore, MN must be parallel to BC. Okay, so the first thing we had to do was to show that MN is parallel to BC. And as I said, with geometry, it's all logical and it's all deductions. So we can't just go straight away to showing M is the midpoint. We first need to have a little bit of work. We need to first think about how do we prove that MN is parallel to BC. Obviously, if we prove M and B are corresponding angles, then therefore MN is parallel to BC. So since MN is parallel to BC, and we know that N is the midpoint. Okay, and I'm writing it all out in quite a bit of detail for those of you who do struggle with geometry. So, and N is the midpoint of AC, therefore M must be the midpoint of side AB. All right. So M must be the midpoint of side AB. Now the reason for that, because remember guys, you cannot make a statement unless you can back it up. That's very, very important in geometry. You cannot say something without having a reason to back it up. Because remember, whenever we mark geometry questions, you don't get a mark just for a statement. You also get a mark for your reason. So if you just said, okay, well, therefore M is the midpoint of AB, no reason, you're going to lose half a mark because you haven't given us a reason. So we know that N is the midpoint of AC, MN is parallel to BC, therefore M is the midpoint of AB, and the reason for that is the converse. And you can abbreviate with obvious abbreviation, so it's the converse of the midpoint theorem. All right. So there we used the converse of the theorem. Let me go to the diagram again and just show you what we've done, what we've proved. We said N is the midpoint of AC. We then proved that MN is parallel to BC. Since N was the midpoint of AC, since MN was parallel to BC, this then implies that M must be the midpoint of AB, and that's simply the converse of the midpoint theorem. Okay, hopefully you've all got that and you've all followed that. All right. Then the next part of the question says also show that MN is equal to RC. Okay, so MN, the one that we just worked with now, prove that that is equal to RC. Okay, we know that for a fact, we know that MN is equal to a half of BC, and the reason we know that MN is equal to a half of BC, that follows straight from the midpoint theorem. Okay, so MN is a half of BC, midpoint theorem. Okay, but now how do we get this RC involved in the whole equation? Okay, let's have a look at how we would do that. And I'm just going to erase everything else that we've got on here. And let's use a different color. All right, so the aim is to prove that this one, RC, is equal to that one, MN. How are we going to go about proving it? Well, we know that N is the midpoint of AC, okay? We also know that, well, we don't know it yet, but we can show that RN is parallel to AB. So what I've done is I've switched the diagram around a little bit, and we can show that that is parallel to that using our corresponding angles as we did before with B and R. So it stands to reason that if NR is parallel to AB and N is the midpoint of AC, then that means that R must be the midpoint of BC. So let's set up this proof. So we're going to say, since N is the midpoint of AC and NR is parallel to AB, and this was similar to the proof we did to show that MN was parallel to BC. NR is parallel to AB, and the reason for that is corresponding angles. And the corresponding angles here were B and R. They were both equal to 90, so therefore they were corresponding angles, so that makes Rn parallel to AB. So N is the midpoint of AC, NR is parallel to AB, so what that means is that, if you follow the reasoning, it means that R must be the midpoint of BC, and that's just the converse of the midpoint theorem. So therefore, R is the midpoint of BC, and your reasoning there is the converse of the midpoint theorem. Now, why did I need to do that? Why did I need to show that R was the midpoint of BC? Because what that's going to now mean is that BC is actually made up of BR plus RC. Okay? So BC is made up of BR plus RC, but RC is equal to BR. So therefore, in place of this BR, we can say RC, because they're both equal to each other. They're equivalent lengths. So BR we can replace with RC. So actually, BC is 2 times the length of RC. How does this tie back into the question? Well, we know that MN is a half of BC, and this was from the midpoint theorem, which we proved previously. So MN is a half of BC, but BC is actually equal to 2 times of the length RC. So therefore, MN is going to be a half of 2 times RC, and then a half times 2 is just 1, so therefore MN is equal to RC. Okay, so it's quite a long roundabout way to prove it, guys, but basically all we've done, okay, just to simplify it and help you guys understand, is we just simply showed that R was the midpoint of BC. The reason I wanted to show that R is the midpoint is that once R is the midpoint, we can say that BC is made up of basically 2 times RC, because RC plus BR are equal. So instead of saying BC, we can rewrite that as 2 times RC, or RC plus RC. And since we know that MN was a half of BC, well, a half of BC is actually the length of that side, RC. So therefore we could show that MN was equal to RC. So it seems like a complicated way to do the whole proof, but if you follow it in steps, it was all necessary to get us to that point. Another really nice thing about geometry, and this is one of the reasons I like it, is there's more than one way to do any question. So just because I did it in this way doesn't mean it's the simplest, easiest way to do it, although generally as maths teachers we try and look for the simplest, easiest way. You might see another way to do it, and as long as you use the correct theorems and you use the correct logic and you state your points, when you make a statement, give a reason. If those reasons are correct and your statements are correct, then you will still get full marks. Okay, so there's more than one way to skin a cat in geometry. All right, Abraham, do we have any questions?
I have a question from Numfundo Gianni. She says, isn't MN parallel to BR?
MN is parallel to BC, the whole length of BC. All right, so it's also parallel to BR because BRC is one straight line. So MN is parallel to BR, but it's also parallel to BC, which is the whole length of that side of the triangle. So you remember your theory and all of that from straight lines that you've done before. Since MN is parallel to BC, and since BR is part of that straight line BC, it makes sense that MN is parallel to BR. So that is a correct statement, but it really doesn't help you to get to the end of this proof. All right. Is there anything else?
Nothing for now. I like what Leuhang Madumela says. He says, I didn't know that geometry is a fun subject in my school. In my school, they make it so difficult, but hey, you guys are making it simpler and straightforward.
Okay,
so big ups to mindset.
Great. So maybe it's time for us to take a quick break before we continue. What do you think?
I think we can take another an ad break. Indeed. And taking another ad break, here's a comment from Mr. Capital. Mr. Capital also says, geometry is the easiest of them all, same as statistics. I hope you mindsetters also agree to that. But otherwise, if you still have any questions and you still find some difficulties, and you are writing your test, because some of the mindsetters on the page are saying tomorrow they're writing their test, and you're still unsure and not ready, make sure that you hit us on Facebook, because currently we're having about 51,500 likes. So mindsetters, be on the page, ask us some questions, and let's help one another. See you after the break. Welcome back, mindsetters. Now, the greatest pleasure in life and attitude is doing what people say you can't do. So if you think geometry is difficult for you and you can't do it, change that mindset, because you can do it. And that is the greatest pleasure ever in life. In that note, let's continue, Natasha.
All right, guys, so geometry has a bad rap for absolutely no reason. As I said, if you know your theorems and if you're quite a logical person, you know, it's the same as those Sudoku puzzles. You know, you've seen them in the paper where people think you've got to be good at maths to do that. No, you don't have to be. All you've got to have is a lot of logic, and if you're quite a logical person, you can be good at geometry without really being good at maths as a whole. All right, but hopefully you're all getting a lot better at maths having watched Mindset. So we're carrying on with our geometry questions, and we're going to deviate a bit now. We've been looking at the midpoint theorem and the converse of the midpoint theorem, but for question 3 and 4, we're going to use the properties of a parallelogram to help us solve these questions. Okay, so this is question 3. They tell you that KLMN is a parallelogram, and they then give you the value of angle L, which is x plus 10, and K is 3x minus 30. They say determine with reasons the value of all the angles, K, L, M, N. Now, obviously, in order to answer this question, you need to know the properties of a palm. If you don't know the properties, it becomes very, very difficult to answer the question. But if you do know the properties, it is quite simple. Okay. What's really nice about a palm is we know that both pairs of opposite sides are parallel, as I've indicated in the diagram. And once you've got parallel lines, you've got all those nice angles. Remember your fun diagram? Okay, so geometry is fun. The F is corresponding angles. The U or the C is co-interior angles. And the N or the Z is alternate angles. So once you've got parallel lines, you can look out for any of those three. Okay, so how are we going to use it to help us in this question? Well, we know that K is 3x minus 30. We know that L is x plus 10. But if you look at the shape of that, if we draw an outline, those form sort of an upside down U. So therefore, those are co-interior angles. So we can say angle K plus angle L is equal to 180 degrees. Now remember, with co-interior angles, they're not equal angles. They are supplementary. So co-interior angles, and therefore K plus L is equal to 180. Co-interior angles, and if you need to state the sides that are parallel, it's going to be Kn is parallel to Lm. So Kn is parallel to Lm. All right. Now angle K, they told us had a value of 3x minus 30. So therefore 3x minus 30 plus angle L, which was x plus 10. Those, if we add them together, should give us 180 degrees. So therefore 3x plus x gives me 4x. Minus 30 plus 10 is minus 20. That's equal to 180. So we get 4x is equal to 180 plus 20, which is 200. So therefore, x is equal to, we divide both sides by 4, and we get 50 degrees. So therefore, x is equal to 50 degrees. Okay, once you've got the value of x, okay, that's why it was necessary to set up this equation, because without this equation, we don't know what x is. When we set up the equation, we can solve for x. Once we have the value of x, to find the value of angle k, we simply substitute. We know that k is 3x minus 30, but we know that x is 50. So you can simply put that in, substitute it in. So we're going to get 3 times 50, which is 150, minus 30, and that's 120. So therefore, angle K is 120. Then we know angle L is equal to x plus 10, but x was 50. So therefore, angle L is equal to 60. And now, guys, it needs to make sense, because if we look at L is 60, K is 120, and if we do add them, 120 plus 60 is 180. So therefore, yes, they are in fact correct. Okay. Now, how do we find angle N and angle M? Well, we can use co-interior angles again, or we can simply state angle N is equal to angle L. And the reason for that, N is equal to L, because opposite angles of a palm are equal. So therefore, N will be equal to 60 degrees. And this is simply because of opposite angles of a palm. All right. And then similarly, M is equal to K is equal to 120. And your reason again is opposite angles of a parallelogram are equal. Okay, so you see, once you know your properties, you're able to apply those properties, and once you can apply those properties, it becomes really easy to answer the question. So all we used here was the fact that our parallel lines gave us co-interior angles, and then we used the fact that opposite angles of a palm are equal to help us solve for x. All right, so I've got one last question to do on parallelograms using the properties. Hopefully you are all following. I'm going to quickly cross over and check with Abraham if you are in fact following. Abraham?
Right. Natasha, I have a quick question from Trisha. Trisha says, I actually need advice. What is the easiest way to have the theorem in your head?
There's really no easy way. It's the same as learning geometry.
On someone else's head.
You've got to, it's the same as, not learning geometry, it's the same as learning history. You've got to just learn it over and over again. But also, guys, remember with maths, the big thing is practice, 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 because practice does make it better. And it's a boring old saying that we say over and over again, but maths is like golf. The more you practice, the luckier you get. Okay, so you can only improve your swing in golf by practicing 1,000,000 times. It's the same with maths. You've just got to do it over and over and over again until it sinks in, and it will sink in, and that's the good news.
Right, nice one.
All right. Okay, guys, so we're going to continue with our question 4, again using a parallelogram and assuming that all of you know all of the properties in order to answer this question. All right. So this is question 4. They say given parallelogram ABCD with AE and FC. So that's just, AE is just a line, FC is just a line. They also tell you that AE bisects angle A. Bisects, remember, cuts in 2 equal bits. And then FC bisects angle C. So FC also cuts angle C into 2 equal bits. But then ask you to write down all the interior angles in terms of Y. Okay, so let's have a look at that part first before we look at part B, and I just remind you of what the properties of a palm are. All right, so the big piece of information they've given you here, well, 2 big pieces. They tell you that the big shape ABCD is a palm, so there's lots of things you know from that. We know that that means that AB is parallel to CD. How do we know that? We didn't make that up. It's one of the properties of a palm. BC is also parallel to AD. Okay? We also know that the whole length of AB is equal to CD, and the whole length of BC is equal to AD. Okay, all follows from properties of a palm. They tell you that FC bisects, so it bisects, which means cuts in two equal pieces. So therefore, if FC bisects angle C, so if we call this C1 and C2, well then C1 will be equal to C2. Similarly, they tell you that AE bisects angle A. So if we call this A1 and A2, and here they tell you that A1 is Y, then A2 is also going to be Y. All right. And they ask you to write down all the interior angles in terms of Y. So let's get started. Okay. First one that we can do quite easily is we can say, now if you're going to write A1 and A2, make sure on your diagram sheet you indicate which one is A1 and A2. Otherwise, name your angles with the letters. So, for example, this A2 would be BAE or FAE. All right, I'm going to use A1 and A2 because it's obvious from the diagram. So the first simple one is angle A2 is equal to Y. Remember, statement has to be followed by a reason. The three upside down triangle dots, that means since. So A2 is equal to Y since it was given that AE bisects angle A. All right, so A2 is equal to Y. Then we look at the whole of angle C. Now remember, ABCD is a palm. Okay? And in a palm, we know the opposite angles are equal. So angle C is equal to angle A is equal to 2Y. Why is it 2Y? Because A1 plus A2 is equal to 2Y. So therefore, angle C is equal to A is equal to 2Y. Reason, opposite angles of palm. Okay, and I'm just abbreviating there to palm. So C is equal to A is equal to 2Y. But we know that that line FC bisects angle C. So we know that angle C is made up of C1 plus C2. And if they're both equal to 2Y, then we know, bisecting it, we're going to get C1 is equal to C2 is equal to Y. All right, so therefore these two little pieces here are also going to be Y. Okay. All the interior angles, so we've only done A and C, we need the rest of them. Angle D is going to be 180 minus 2Y, and the reason for that is going to be co-interior angles. So angle D, so A plus D is equal to 180. That's co-interior angles. So therefore, we got that D is equal to 180 minus 2Y. All right, we can get B by saying B is equal to angle D because of opposite angles of a palm. So therefore, B is going to be 180 minus 2Y. All right, so we've got that one. Okay, but we're not done. So we've only got the interior opposite angles. We also need all these little pieces in between. Okay, so angle E, if we call this one here angle AED, that's going to be equal to Y. And the reason angle AED is equal to Y is because of alternate angles. So it's equal to A2 because of alternate angles. All right, so if we look at your Z shape, there we go. So angle E is equal to angle A2 because of alternate angles. All right, this angle here, angle A, well, what do we want to call this? AEC, that's going to be 180 minus Y because of angles on a straight line. Okay. Similarly, we can find that angle F1, if we call it that, is going to be Y because of alternate angles. And then the one on the other side of it is going to be 180 minus Y because of angles on a straight line. Was it necessary to find all of these angles? Absolutely. And the reason for this is with geometry, a lot of the times you'll find that one question leads you on to the next one. So yes, we did have to find all of these angles because as you're going to see in the next question, we're going to use it. All right, and the next question says, prove that AF EC is a parallelogram. So the little piece in the middle, we need to prove that it's a palm. Now guys, before you can even try or attempt to prove that it's a palm, you need to remember the properties of a palm. Because obviously if you don't know the properties, then you can't prove that it's a palm. It's as simple as that. Okay, so that's the little orange piece that we're trying to prove is a palm. So what I want to do is just remind you of the properties of a palm, because if you have this in your head, it makes it much easier to attempt a question like this. All right. There are really 5 ways to prove that a quadrilateral is a parallelogram. The one thing you can do is prove that the opposite sides, both pairs of opposite sides, are parallel. Okay. You can also show that both pairs of opposite sides are equal, then it becomes a palm. Or you can show that the opposite angles are equal. If the opposite angles are equal, it becomes a palm. Or the diagonals bisect each other. So if the diagonals bisect each other, once again, it becomes a palm. Lastly, you can show that one pair of opposite sides is parallel and equal. So if you have a shape like that, if you can just prove, for example, if that's AB and CD, if you can just prove that AB is parallel to CD and that AB is equal to CD, then that's also sufficient information to show that that shape will become a parallelogram. Okay, so remember those 5 points. You either prove both pairs of opposite sides parallel, both pairs of opposite sides equal, the opposite angles are equal, the diagonals bisect each other, or one pair of opposite sides is parallel and equal, and that then shows that it's a palm. But please don't now go and show every single one of these. You only need to show one of those 5 points. Any one of those 5 points is sufficient to show that a shape is a palm. Okay, let's go back to our diagram and see what's going to be the easiest way to prove that this is a palm. Okay, so we've got diagram, this little shape AFCE. We want to prove it's a palm. And the thing that's glaringly obvious to me, maybe not to you guys, but because I've made the diagram so messy, but the thing that's very obvious to me is that angle E is equal to angle F, and this angle C1 is equal to angle A2. So since both pairs of opposite angles are equal, this shape becomes a palm. All right, so to set it up quite simply, so we're going to say, just looking at the diagram, we can say A2 is equal to C1, all right? And we've already proved that before when we were trying to find all the angles, and angle F is equal to angle E. So therefore, AFCE is a palm. And the reason for that is that both pairs of opposite angles are equal. Obviously, you will write your reason in. Both pairs of opposite angles are equal, therefore the shape is a palm. All right, so that's the quickest, easiest way to show that specific question. All right, guys, so hopefully that you've taken out of this lesson that geometry really isn't that difficult, and there's lots of different ways to approach a question, so make sure to give it your best shot.
Thank you so much, Natasha. Here's a question for question 3. For question 3, it's from Dlamini Pindo. Dlamini says, in question 3, will I be wrong if I simply used the square BMNR to prove that NR is equal to MB, since we know that the square has all its sides equal?
You'd first have to prove that that was a square. So the one he was talking about is actually question 2. And he would need to show that shape MNBR is a square, which is not that simple, because you have to prove that it's a square. And remember, you've got to look at your properties. So you first have to prove that that's a palm, which it obviously is, but then you need to first show why each of the sides are parallel. So it's not perhaps the easiest way to do it, but that is a possible way, but not the easiest way.
All right, thank you so much. I need to tell you this, mindsetters, before we wrap the show. If you have any teacher that you think they're amazing and you'd like them to enter for the Stars in Education Awards, make sure that you go to www.ed.org.za, find the form there and nominate your teacher if you know and you reckon that you have the best teacher ever. So get all those nominations on that website, which is www.ed.org.za. The closing date is the 7th of September 2013. But from us with Natasha for Great Hands, that's it, guys. Thank you so much. And if you still have some questions, go over Facebook. We'll help you through. And also you can send your emails to our help desk. Otherwise, thank you so much. Peace.